Hello friends, I welcome you in lecture number 23 on Laplace transform. In this lecture we will see how to find out inverse Laplace transform using partial fractions. So we understand with the help of this example, find the inverse Laplace transform of the function minus of s plus 10 divided by s square minus s minus 2, and this question was asked in GTU Winter 2010 exam. Now we have seen in earlier lectures, in the lecture before this we have seen that suppose we have quadratic factor which is irreducible. Suppose I consider this quadratic factor, then this cannot be written as product of two linear factors. I cannot factorize this quadratic factor in terms of linear factors. So if I have this type of quadratic factor, then we can use first shifting theorem. We can write down this quadratic factor in this form: s minus a square plus square of some another constant, and then we use that formula for first shifting theorem. But suppose our factor which is in the denominator, for example here in the denominator we have s square minus s minus 2. This is quadratic factor, and we can factorize this into linear factors. So in that situation we have to use method of partial fractions. This we can rewrite as, here middle term is minus s, that I can rewrite as minus 2s plus s, and we can take s common from first two terms. So s common and we are left with s minus 2, and this we can rewrite as 1 into s minus 2. Now again we can take this s minus 2 common, and we are left with another linear factor s plus 1. So it is possible to write down this quadratic factor as a product of two linear factors, s minus 2 and s plus 1. So we can now write this function. Suppose we do not consider negative sign, then we have s plus 10 divided by s square minus s minus 2. This I can rewrite as s plus 10 divided by s minus 2 times s plus 1. Now this function s plus 10 over s square minus s minus 2 is division of two polynomials in variable s, and here degree of numerator is 1, degree of s plus 10 is 1, and degree of this factor is 2. So here degree of numerator is less than degree of denominator. So this type of rational function is called proper rational function. And if we have proper rational function, then we can write it in terms of partial fractions. So as we know, because I am having two linear factors, I can write this as a sum of two partial fractions. Here I write s minus 2, here I write s plus 1. Now degree of s minus 2 is 1, so here I will write constant or polynomial of degree 0. Here degree of s plus 1 is 1, so here also I will write another constant, that is I will write polynomial with degree 0. So because this is proper rational function, we can always write it in terms of partial fractions. Now once we write down this as sum of two partial fractions, then we have to determine these two constants a and b. So for that we multiply this whole equation by this product s minus 2 into s plus 1. So if I multiply this whole equation by s minus 2 into s plus 1, then in this term I will be left with s plus 10. If I multiply this term by this product s minus 2 into s plus 1, then s minus 2 will cancel out, and I will have a times s plus 1. Similarly, if we multiply this second term by this s minus 2 into s plus 1, then s plus 1 will cancel out and we will have b times s minus 2. Now in this equation, we will put particular values of s and we will find out these two constants a and b. So which values we have to put, so that we can decide by taking these two linear factors equal to 0. I take s minus 2 equal to 0 and I obtain s equal to 2. So I will put s equal to 2 in this equation number 1, and similarly if I take s plus 1 equal to 0, then I will obtain s equal to minus 1. So first I put s equal to 2 in equation 1. If I take s equal to 2 in equation 1, then left hand side will be 2 plus 10, that is 12, equal to a times 2 plus 1, that is 3, and b times 2 minus 2, that is 0. So therefore we will have a equal to 12 by 3, that is 4. So for s equal to 2 we will obtain value of a. Now similarly we put s equal to minus 1 in equation 1. So left hand side will be minus 1 plus 10, that is 9. If I take s equal to minus 1, this will be 0, and b times minus 1 minus 2, that is minus 3, and therefore b equal to this negative sign and 9 divided by 3, that is minus 3. So we have obtained values of a and b that we substitute here now. So now our function is reduced in terms of partial fractions. Our function is s plus 10 divided by s square minus s minus 2. This is equal to a divided by s minus 2, a equal to 4, and b divided by s plus 1, value of b is 3. So we have a divided by s minus 2, b divided by s plus 1, and a equal to 4 and b equal to minus 3. And in the question we have negative sign, so now we multiply both sides by minus 1. Therefore minus s plus 10 divided by s square minus s minus 2, this is equal to negative of 4 divided by s minus 2, and here negative negative positive, 3 divided by s plus 1. So now you can see our function on the left hand side is converted in terms of those functions whose inverse Laplace transform formula is known to us. We know that L inverse of 1 divided by s minus a is e raised to at. So now we can use this formula and we can obtain inverse Laplace transform of given function. So inverse Laplace transform of s plus 10 divided by s square minus s minus 2 equal to minus 4 times L inverse of 1 divided by s minus 2 plus 3 times L inverse of 1 divided by s plus 1. And using this formula, if we compare with s minus a, value of a is 2. So this is minus 4 times e raised to 2t plus 3. If we write s plus 1 as s minus minus 1, then value of a is minus 1. So this is 3 times e raised to minus t, and this we can rewrite as 3 times e raised to minus t minus 4 times e raised to 2t. So this is the required inverse Laplace transform. So here we have used this partial fractions to write down this function in terms of those functions whose inverse Laplace transform formulas are known to us. We don't have formula for inverse Laplace transform of this function. So using partial fractions we are able to write this function in terms of this type of functions 1 over s minus a, and using this formula we are able to decide the inverse Laplace transform of this function. So you can have this type of problems also. So whenever you have this type of rational function, first step is try to factorize whatever denominator is given to you, and if you can factorize, then try to write down given function in terms of partial fractions. So I stop here. In upcoming lectures we will be discussing another examples of this type in which we will use partial fractions. Thanks for watching.